In this video, we're going to look at linear equations. More specifically, we're going to compare parallel and perpendicular slopes. If two lines are parallel to each other, they're never going to intersect. This is true because they have the same slopes. Their y-intercepts are different, but their slopes are the same. And the symbol that we use is two lines together, almost like the two L's in the word parallel. Sometimes they're written on diagonal, and sometimes they're straight up and down. If two lines are perpendicular to one another, they will intersect, but more specifically at a 90-degree angle. Their slopes are opposite reciprocals. That is key, just as parallel lines having the same slopes. The fact that perpendicular slopes are not only opposite, they are also reciprocal. And if we think back to earlier video looking at properties, we remember a discussion about opposites and reciprocals. Opposites are positive and negative. Reciprocal is if we have the fraction a over b, for example, the reciprocal, what brings the denominator b to the numerator, and the numerator a to the denominator. Perpendicular lines are denoted by this symbol. It's an upside down capital T. Example 1. Complete the following table. Here we're given three different slopes, and we're asked to find the parallel and perpendicular slope to it. So we look first at -2/7. A parallel slope would be the same. A perpendicular slope would be opposite reciprocal. And reciprocal. Opposite. So it was negative, it's now positive. Reciprocal. The 7 was the denominator, which now is the numerator. The 2 was the numerator, which now is the denominator. 7/2 is perpendicular, that slope, to a slope of -2/7. Given the slope 5, the parallel slope is 5. The perpendicular slope is opposite, so now negative. 5 becomes the denominator. What's the numerator? 1. Because any integer is also a rational number, which can be written as a fraction over 1. These slopes are opposite, positive, negative, and reciprocals, 5 over 1 and 1 over 5. So they are perpendicular to each other, the slopes. Parallel slope to 0 is 0. What is the perpendicular slope? Well, 0 now comes to the denominator, and the numerator is 1. Oh, but we can't have 0 in the denominator, so this is undefined. This was a horizontal line. And this slope would be from a vertical line, as we review the last video. In this next example, I've given you several lines together, paired them up, and want to know if they are parallel, perpendicular, or neither. In order to determine this, it's helpful to get our lines into y equals mx plus b form. so that we can identify what the slope is very quickly. Subtract 3x from both sides of the equal sign. Negative 2y equals negative 3x plus 6. Again, I choose to put the negative 3x first because the equation y equals mx plus b, the x term comes first, so we will choose to write the x term first. It will help us find slope more accurately. Divide by negative 2 every single term. Y equals negative 3 divided by negative 2 is positive 3/2. X plus, actually, minus, because 6 divided by negative 2 is a negative 3. The slope is 3/2. The slope of this line, it's already in slope-intercept form, is negative 2/3 because that is the coefficient of the x. These are not the same, so these lines are not parallel to each other. But 3 is in the numerator of this slope and the denominator of the second. 2 is the denominator of the first and the numerator of the second, so they are reciprocals. And the second one is negative when the first one is positive, so they are opposite reciprocals, and therefore these lines are perpendicular. Example B. Again, getting this into slope-intercept form. I'm going to choose something different here. I'm going to actually add y to both sides of the equal sign so that y is positive. And then subtract 4 so that y equals 2x minus 4. This is still slope-intercept form, y equals mx plus b, where the slope is positive 2. I look at the second line, and we're going to isolate y again, getting this into slope-intercept form by dividing every term by the coefficient of y, which was 2. So y equals 4 divided by 2 is 2, x plus 3/2. The slope here is 2. Both slopes are the same, so the lines are parallel. Example C. Similar to the example B, I have a minus 1y. This time I will simplify doing by keeping y on the left side. So we'll subtract 2x first. This way you can see the difference. Negative y equals negative 2x plus 7. Don't forget to divide by the coefficient of negative 1 every single term. That's often forgotten, which is why I chose in example B to add y to both sides, which would be perfectly acceptable here as well, but I wanted to point out this to you. So y equals positive 2x minus 7. So the slope here is 2. The second line, we subtract 2x from both sides. Y equals negative 2x plus 6. The slope here is negative 2. Both slopes have a 2, but their signs are opposite. So these are opposite slopes, therefore perpendicular. you might say. But that is not true. It is not perpendicular. In this case, it is neither, because not only do they have to be opposite, they also have to be reciprocals. In order for these to be perpendicular, the second one or the first would have to have been negative 1/2, or the first would have been positive 1/2, and a perpendicular slope would be negative 2. These would be examples of perpendicular slopes, but the slopes that were given are neither parallel or perpendicular.